No, this is Mrs. Ward, and I'm going to go over problem 24 from the class book. So it says the designers of a waterpark are creating a new slide and have sketched some preliminary drawings. The length of the ladder is 30 feet, and its angled elevation is 60 feet. So this is the length, which is 30. This little angle in here is 60 degrees. It says find the height of the slide. So I'm just going to bring this triangle over here. When I do that, this is 60 degrees. My hypotenuse is 30 feet. This is my right angle, and I'm looking for the height. So then what I'm going to do is I'm going to set up my trig ratio. So I have the opposite side that I'm looking for, and the hypotenuse, the opposite of the hypotenuse sine. So I'm going to say the sine is 60 degrees is equal to the opposite of the hypotenuse. So I'm going to take 30 times the sine of 60 degrees. And h, go there and calculate if we want, and you're going to end up with 25.98 is equal to the height. Then the next thing I'm going to do is it says, part B says, find the angle of depression theta from the top of the slide to the end of the slide at the ground in terms of the horizontal distance the rider travels. So when I look at this triangle here, it wants this angle of depression. There's two ways I can set up my triangle. One is I can think of as though I have a rectangle. If I have this rectangle, this h here is the same as this h here. The height would stay the same. This would be my hypotenuse, and then this d would be the same as d. So I have this triangle that goes this way, and this is my h, this is my d, and this is my angle of depression. The other way I can look at it, if I didn't want to look at it that way, is I could think of having two parallel lines. So I would have this horizontal and this horizontal, and then I would be cutting it by this transversal. So alternate interior angles are congruent. So this angle would also be theta. This is still going to be my d, so the adjacent side is still going to be my d. The opposite side is still going to be my h. So I'm just going to use this triangle over here that I drew, but it's the same triangle either way. So it wants me to write the angle in terms of d. I do know my height though. I just figured that out. It's 25.98. So now I have this angle. Opposite side is 25.98. Adjacent side is what I'm looking for. So I'm going to say the tangent theta is equal to the opposite over the adjacent. So remember, when I'm solving this, I'm going to multiply both sides by d first. And I'm going to say d times the tangent of theta is equal to 25.98. And then to solve for d, I'm going to divide both sides by the tangent of theta. So my distance is going to equal 25.98 divided by the tangent of theta. So that's me finding the angle of depression in terms of d. That's okay. The angle of depression of the ride is bound by safety restrictions of being no less than 25 degrees and not more than 30 degrees. So I'm going to find the distance if my angle were 25 degrees. I'm going to put in tangent of 25 degrees. And when I do that in my calculator, I ended up with 55.71 feet. And then the most that my angle could be is 30 degrees. So I'm going to take that 25.98 divided by the tangent of 30 degrees. And I'm going to get, it was 45.998 something, so I rounded back to 45 feet. So the answer to my question is find the interval for how far the rider can travel horizontally. So this rider can go between 45 feet to 55.71 feet. And that would be my answer. If you have any questions, let me know.